Alright, this is part 2 of our GPX assignment, and for this one I'm going to use Eugene, so I'm going to start Eugene. Actually, I already had it started, so let me let it start and then close it. Alright, there we go. Alright, so Eugene is started. Here's what it looks like. You go here to Tools, you drop down to Build Dot Plot, and we have our two sequences. So we're going to go find them. I put mine on my desktop, so you should go find similar things. Now I'm going to start with the human one. You actually doesn't really matter which one you do. It's just going to put them on a different side of the page, either the top or the side. And then I'm going to choose chimp. So I have human, chimp. You might want to compare them to themselves. That's something you could do, just to see what it looks like, but we'll do that as a different exercise probably. Then I'm going to go next. Alright, and here I have my two. Now I absolutely want to do inverted repeats. Alright, and I'm just going to leave it at 100% for the first view. So search for repeats, search for inverted repeats, 100 and 100 here. Actually, let's not leave it at 100. Let's hit this little 1K, and it says 6 is the best one for this size. We're going to leave it at 100% though, and I'm going to go OK. And actually, that's a pretty good view right there. So if you'll notice, what do we see? We see 3 good solid lines. Realize one of these is genomic and one of these is RNA, and what this is telling me, it actually is quite similar between the human and the chimp, and we definitely see where the introns and exons are. So the exons are going to be where these lines are, and the introns are going to be where the gaps are. So right there you have useful information about your sequence. So now the question is, what can we learn? Well, we need to learn about these and see how similar they are. Now that would be back in your BLAST results. Your BLAST results would give you these 3 all aligned. So you might go back and do a BLAST now. This is a visual one, and so visually you can see this. Now your BLAST results, what BLAST gave you at the bottom where it does the align. So if you do a BLAST, and when we receive that and we scroll down to the bottom, it would have given you an alignment. We actually can get that here. If I click on, say, this one, alright, it's showing us the same thing BLAST would show us, this right here. But BLAST shows us where they're different. But this is the sequence that we are looking at, and here are the 2 of them. Now they're not perfectly aligned. CAAA, CAAA, C and 3A is GT. Pretty close though. So this is, which one is which? Hard to tell. Looks like the top one is the chimp. So the chimp is here and the human is here. I think that's true. Might not be the case. No, human is on top and the chimp is on bottom. Anyways, so you can click on these and see how this becomes slightly red. This one will be too long. That's going to be hard to look at in this manner. So it's probably better to go back, and if you wanted to look at the actual sequences, which you do, you might go back to the BLAST, and I'll do that here in a second. But we can do some other things here. There are tools here, and let's see here. We can go tools, and we can do RNA. Let me find it. We can do a BLAST here. From here, it'll go do it. But I want to do a sequence alignment. And me personally, I like, these are all essentially different ways to do the same thing, which is to find an alignment. I like K-align. I'm going to go here and I'm going to go put input file. Now the thing is, an input file for this, it's the 2 sequences combined into one, and we haven't done that. So I'm going to have to cancel here, and I'm going to have to create a K-align input file. So how am I going to do that? I'm going to create a new document, Now you have to do this in your text editor. And I'm going to call it line GPX 8 / HS chimp. All right, and we're going to call that a FAST day. All right, and what I'm going to do is I'm going to put our other two files into the one file. I'm going to merge them. So I'm going to take the chimp file, and it doesn't matter which one you put in first. And I'm going to, where is it? It's going to be our third one here. I'm going to paste that one in, and then I'll go over here to the human one, and I'll leave a space, and I'll paste that one in. Oops, I shouldn't have closed it. It's right here. All right. Your system, of course, is going to be different. So I put a space there, and then I'm going to paste the other one. So yes, just like this. And then I'm going to save that. And this will be the file that I put into the alignment editor. So we go back here to, where was it? Multiple sequence alignment, and I'm doing K-align. So my input file, I go to my desktop, and the one I said align. Alright, and that's going to align that. Now we also have to name our output file. So I'm going to copy whatever is up here, and I'm going to paste that, and I'm just going to change the extension. Instead of output, I'm going to call out, just to tell me that that's the out file for this input file. And we will leave these blank. We may get to some explanation on how to adjust these to fine-tune it, but for now the defaults should be just fine. And so I align those. Now you look at this down here and it tells you how far it's gone, and there we go, we have aligned it, and this is much prettier. That's why I wanted to show you to do this. You could do this with Blast, but you can see that this is a much prettier outlook. It's easy to see where they're the same and where they're different. So you can see here GPX 8, there's a little difference here at the first view, but then it starts aligning pretty quickly. Let's see, and we can just scroll along here, and you can see it's very similar. Very similar. Here's the difference right here, a G and an A. So there's a mutation between us and chimps. Anyways, I thought I'd show you this one because this one looks better. It's easy to see where the differences and the changes are. So if you want to do it this way versus the Blast one, oh, here's another mutation, a C and a T. And this is how we align them. And look, essentially this is what dot plot, this is zooming in, whereas the dot plot is bigger picture. And that's what I want you to see. I'm not as interested in you doing this one as much as I am you doing the dot plot and getting some general information about the organism. So I want you to copy the picture, as in let's go back and do that. So let's go back to our build dot plot. We'll do it one more time, and I will go to the chimp here, and I will go to the human. We open those up. Alright, and we go next. Alright, and we click the auto. Now it's saying 7. That's because I switched them. We can do auto. Depending on the size of the first one, I think is what determines that. So 7 shouldn't give us any difference. But notice it looks a little different. Oh, did I do it against itself? I did. I actually compared it against itself. That's when we got the 7. Alright, let's redo that. Let's go here to Tools. build dot plot, and let's go to the let's do human first. I don't remember what we did first time. There's our human one. Then we'll go to chimp. Alright, that should be fine. We're going to go here. It's 6 7 inverted repeats. Maybe I didn't go inverted repeats first. Now, what am I doing? We're not getting the same results. Did I change something? Here's the one we got first. This is the one that we want. Don't know what I was doing there. Do it like I did it the first time. You were watching me. Let's see here. We want it to show that it's like this, and to save the picture, which this one is the one I want you to save. You can export sequence regions. Wait, copy paste. Well, I know there's a way to export the JPEG. Let me see. Dot plot. Oh, save. All right, save as image. So you go up here to dot view. You're on here. You right click. You go save and load. Save as image, and you can save it as a JPEG, bitmap, or PNG. I'm okay with any of the three. Just make sure you know where you're sending it, and export. Alright, and it should have put it, I believe, in the same folder. No, it probably put it in pictures, maybe. Let's see where mine put it. Yours may put it in a different place. We have to read. No, probably put it wherever I have installed Eugene. Let's see here. Data and samples, scripts, weight matrices. I do not know where it put it. That's important. So you need to find out where it's putting things. Let's do it again. And I'm going to go save image as, and here's, see the file name. Let's see where. Here I can choose where to put it. I put it under. It puts it under documents in mine. That's funny. Okay, so it's went under documents. I'm just going to put it on the desktop. Alright. Alright, now we'll go look at it. Should be along here somewhere, right here. So I can open it with, and there we go. So you can use that image in a document that you do for your homework. Now, what is this telling us? Of course, it's telling us here's our genomic data. We also can see that it's very similar. Not only that, I do an alignment. Now you can go back to the BLAST results and kind of see an alignment, and that might be much quicker than what I just did. If you want to combine them into one file and do the alignment in Eugene, you can do that. But BLAST results, when you blast it and get the result, you get that same type of alignment down at the bottom. Let me go back and show you that actually. Let's do that, and before I end this this video. So I'm going to go back, and we'll go to blast in. Alright, right here. And what we did was, I'm going to choose the file this time instead of cutting and pasting, and we're going to go to desktop, and I'm going to put the human GPX in right here, this one. Alright, and so I've chosen that file, so instead of cutting and pasting in, I've chosen it. And of course we're going to do organism, and we did pan troglodytes. Alright, we did this, and then I blasted. So again, we're doing the same thing. Now, if they don't align very well, you have to go and look at the sequence a little more. That's why I'm saying this, that you need to do the alignment and look at the alignment, not just the dot plot. So you actually need to look at the letters, is what I'm saying. Let's get this in here. The last one, it should come up now. Did it with 19 seconds last time. Here we go. All right, so we chose this first one. So if I click here, we clicked here and got the sequence, but we didn't look at actually how the alignment went. So when I click right here, it's going to move us down, and this is further down from up here. Or, and actually it didn't, it gave us a whole new page. But this is the alignment. So you can see where the gaps are by where the lines are missing, and there aren't very many right here, the C and A. This is a little harder to read. All right, then we have a gap. This is the next, the first exon would be this one, and then here's another smaller one and another one. Oh, these keep going. Make sure you stop on the right parts. So here, length 1,387. Here's another one. Here's another one, and then we go to the next one that you click on. So it's just these first three. These first three align because there were 3 exons. All right, so you get these 3. Now you might get one long sequence. You might get several small ones, but just realize that when you click on this, oops, let's go back. All right, when you click on this, if you scroll down here to the bottom of all of these, no, they're not doing that anymore. All right, you actually have to click on them. So when you click on them, it sends you to a list of these and all of the things. It's just hard to discern when you've jumped from one. So here's the first entry that we clicked on. This is what we clicked on in the previous page. And then there were 3 parts, and we know that because we saw the dot plot. All right. And okay, this one, I don't know what I did the first time to see all of them, but you did just get 3 here. All right, that's good. So these are the 3 that you would want to look at as far as the alignment goes. So 1, 2, 3, and it gives you some statistics. And your answer would be they're not too different, though they are not completely the same. You're looking for little gaps, and like I said, you could do this, or you could do it the way I did it in Eugene. Eugene's a little easier. It's more colorful, easier to see the differences. Here's a piece that's been deleted. Now you have to keep track of which one is which is the query and which is the subject, as in which one is the chimp and which one is the human. Usually the query is the one you're searching in. Let me think which one. So pan-troglodytes would be the query. No, the longer one. The longer one is going to be the human one. So whichever one is the longest, that looks to be the top one, that's going to be the human. The chimp was the one that was RNA. That's the subject. Well, this is the out a little bit too. What did we do? We have the all right. Used Eugene to create a dot plot comparing the 2 sequences. All right. We looked at the sequences either in BLAST or in Eugene. We saved the going to save the dot plot as a JPEG or something, as a picture. I'll say JPEG, PNG, or bitmap. Alright, and you save that. You will add that to your analysis for. So you describe describe the results. In other words, are they similar? Slash how similar? Similar. What's missing? Identify what is missing, etc. Alright, so that's kind of what you're describing. Now then, of course, part 3 is do it for all sequences. Repeat for all sequence combinations as discussed in class. Alright, including human versus human. So there should be, I believe, 6. We decided there were 6 that we were interested in class. Human versus human, human and 1 versus 1, and 1 versus 2 versus 2, and that sort of thing. All right, that's our assignment. First assignment. I will give you another assignment this week, but this is the first one.